Hey guys, Mr. Klein here with our second video of the chapter. The last lesson we talked about the history of the atomic model and the parts of an atom according to our modern theory. Today we're going to talk about the periodic table, and it's another history lesson just for part of the time. And it's just a basic guide to the periodic table. So let's get started. Dmitry Mendeleev, this crazy guy with a beard, was a scientist from Russia, and he made a very important discovery. Now, he knew that some elements had similar chemical and physical properties, and thought that there were important clues to a hidden pattern. And Mendeleev created a series of cards, and he started putting them in order according to the properties that he knew. And he noticed that the atomic mass, or the average mass, of all isotopes in the element started forming a pattern. That a pattern of properties appeared when he arranged them in the elements in order of increasing atomic mass. So in other words, what he did was he put all the known elements he had on cards and he wrote their atomic mass and he put them in an increasing order. And he found that these properties repeated themselves, oftentimes in more robust, if you will, patterns, which we'll talk about a little bit later in class. And what he ended up putting together is this, the periodic table of elements. And a periodic table is an arrangement of elements showing the repeating pattern of their properties. Okay? So if you notice in here, and we'll talk about that right here, going vertically, we have a repetition of properties, and properties change in the same order as we go across the rows. So columns and rows become very important in reading the periodic table and seeing how the elements in a known universe work. And interestingly enough, because the way the periodic table is structured and the way atoms are, even if we go to an alien planet, we can still find these elements because they are the same number of protons, same number of neutrons, same number of electrons, and isotopes and ions and stuff like that, as they would be on Earth. And so we might find some exotic elements that are like bigger than number 118. That's the biggest number we have. But whatever we'll find on other planets or anywhere else in the universe will be in this periodic table already. Now, so what information does this contain? Now, in our textbook, they have 4 pieces of information in their periodic table, but many other periodic tables have even more information. As far as I'm concerned, in my class, we use this website, ptable.com. It's a really cool website that gives you lots of information about the elements in the periodic table, links it to Wikipedia information, basic information about it, and so on and so forth, tells you about the uses and things of that nature. And plus you can change what states of matter they would be based on what temperature they have, which I think is really cool. So we use that. There's apps for Android, iOS, even Windows Phone, for the 5 of you who actually use that. Anyway, that you can use that for. So our textbook and what we use, the very basics of that, has 4 pieces of information. Okay, so we have the parts of our periodic table entries, which we have it right here. So we'll look at the atomic number, the chemical symbol, the element name, and the atomic mass. So let's go ahead and look at this back and forth. First off, the atomic number, of course, is the number of protons an element has. Every single potassium element, every single potassium atom in the universe has 19 protons in it, hence its atomic number. The second one in the entry is its chemical symbol. All chemical symbols contain 1 or 2 letters, and the first letter is always capitalized. Often the abbreviation is from English, but can also come from Latin or other words. So if we look at this, we see like chromium, Cr, or vanadium, right here, you see it's a capital V, but if we look at chromium, or helium right here, we have a capital H and a small letter E. So the first letter is always capitalized, the second letter always lowercase. Sometimes you'll have 3 for these other letters, but they haven't not all of them have exactly been completely and totally discovered yet, which I'll talk about more in class. Of course, below that you'll have the name of the element, and the last piece of information is the average atomic mass, which is the average of all known isotopes in that. And of course, that's listed in atomic mass units, or AMUs. So let's go ahead and let's look at this periodic table entry again. The atomic number right here is the number of protons that every potassium or whatever atom has. We have the symbol. It's either 1 or 2 letters. and occasionally 3 for the couple of undiscovered elements so far. We have the element name right here, and then we have the atomic mass, which is the atomic mass units measurement of all known isotopes. Remember, isotopes are atoms with extra neutrons in them. Now, how is the periodic table useful, you might be asking yourself? Well, in the periodic table, numbers increase from left to right. And the colors correspond to different classes of elements: metals, nonmetals, and metalloids, which you see right here. Okay, and oftentimes they'll have different color schemes, but generally you can color them into metals, nonmetals, and metalloids. If we look at P table, as you can see, the metalloids are here. We have nonmetals right here, and we have metals right here. So the metals, nonmetals, metalloids on there. Now, if you look across a row of a periodic table, you'll see that the elements change in a predictable way. And the elements' properties as a result, because they go in a very predictable fashion, we can predict them based on where they're at in the periodic table. Now, the rows in the periodic table are called periods. Okay, so in the periodic table, we have 7 periods right here. 1, 2, 3, 4, 5, 6, 7 right here. These are the 7 rows. Okay, and the elements change regularly. Okay, metals are shown on the left, and nonmetals and metalloids are shown on the right, with metalloids in between. And the modern periodic table has 7 periods, which form 18 columns. Okay, these columns form what we call groups or families. So as we go back and we look at this, okay, so we have the 7 periods, and then we have the 18 groups right here. Okay, and as you can see on this website, as we go on them, we can go and we can set them up. Okay, we can see them individually. So remember, periods and then families. Okay, periods go across, families go up and down. And the families, well, if we go for group 1 is on the left side, and group 18, of course, is on the right, because the periodic table runs from left to right. And the families all have very similar properties from top to bottom. And the pattern of properties repeat each period. So the elements in each group, like I said, have similar properties to them. And so that's kind of the summary of the lesson. We can take a quick peek at the periodic table some more. But what I was saying is, as you go down here, the families, the higher the atomic number you go in there, the properties get stronger and stronger. For example, these are the alkali metals. They're flammable when exposed to oxygen. Lithium kind of heats up. Sodium gets more and more and more. And francium has like explosions, and you can't really mess with it at all because it's extremely dangerous. It reacts with oxygen so well. But as we go across right here, across the row, what we end up seeing is that we have repetition of chemical properties as we go across. Okay, because they change in a certain fashion in a certain level gradually as we go across. So you consider it like rows on a typewriter. So you start typing, you go over here, you end the line, and then you go back right here. And these two are what we call the lanthanide and actinide series. And if I make this wide and we change this out, what this does is this puts these sets of atoms, which have very similar properties, in this space right here. So in order to keep it and give it space, that be able to put it easily on a page, we put the lanthanide and actinide series down here for there. So there you go. That's the lesson on the periodic table. We will, in our class, we'll be doing a lot of exercises with the periodic table to use it. But my class is essentially middle school, upper elementary, middle school. So what we talk about the periodic table isn't very in-depth. But if you're more of a high school person, of course, you'll be going over this a lot more detail in your physical science and especially your chemistry class. So there you go. That's the lesson on the periodic table. If you have any questions, please let me know. And thanks for watching.